Okay, welcome everyone. My name is Clayton McDowell. I'll be the MC for this session today for our, I think, one of the final sessions for Global Climate Change Week. Today, we're going to be looking at some of the Sustainable Buildings Research Centre initiatives that we have. And we have a couple of lovely speakers, but I want to just start off with an acknowledgement to country. So we acknowledge that country for Aboriginal peoples is an interconnected set of ancient and sophisticated relationships. The University of Wollongong spreads across many interrelated Aboriginal countries that are bound by this sacred landscape and intimate relationship with that landscape since creation. From Sydney to the Southern Highlands to the South Coast, from fresh water to bitter water to salt, from city to urban to rural. The University of Wollongong acknowledges the custodianship of the Aboriginal peoples of this place and space that has kept alive the relationships between all living things. The university acknowledges the devastating impact of colonization on our campus's footprint and commit ourselves to truth-telling, healing, and education. Today's program, as mentioned, we have two fantastic presenters today. Our first one is going to be Associate Professor Georgios Kokkigiannakis, who's going to be speaking on the innovation for affordable heating and cooling. He'll be followed by Dr. Leela Kempton, who will be speaking about our Sustainable Homes Challenge, Homes from Waste. And we're going to finish up the session with a Q&A session. So hopefully 20 minutes for each speaker and then 20 minutes for our questions and answers at the end. I'm welcome for anyone to throw any questions into the chat as we're kind of going. Some of the presenters might be able to answer them as we're going as well along the way. Otherwise, at the end, we can field those questions as best we can, or people can raise their hand and we'll try and give you a chance to open up your mic and ask the questions yourself. But we'll start it off and I'll let Georgios share his screen and kick off with the first presentation.
Yeah, thanks, Clayton. Thanks. Just give me a second. Yeah. So as Clayton mentioned, I work at the Sustainable Buildings Research Centre at the University of Wollongong at the Innovation Campus. But today I'm here to talk about, not about the Sustainable Buildings Research Centre, but a project that we are working on at the Sustainable Buildings Research Centre called the Innovation Hub for Affordable Heating and Cooling. Now, this is a project that is partly funded by ARENA, the Australian Renewable Energy Agency. It's a very large project, total value about $18 million. And ARENA is putting about a third of that. The various partners are CSIRO, our university, Queensland University of Technology and University of Melbourne, and including our university is also putting some cash contribution in this project, which is which helps a lot to be part of this initiative. And one major partner is the Australian Institute of Refrigeration, Air Conditioning and Heating, or AERA, as we call it, and they are really the interface between ARENA and the rest of the partners in the project. Now, what is I will call this iHub, Innovation Hub for Affordable Heating and Cooling. We call it iHub. Essentially, the project is a 2.5 years project that looks to demonstrate how we can better manage the heating, ventilation, air conditioning loads in buildings to shift them towards the periods of the day or of the year when we have renewable energy generation, and in this way maximize the value of renewable generation. Because as you probably know, this crowd here knows that some of the disadvantages with renewable energy is that the loads in the various loads then don't necessarily match together with the generation, so that imposes some restrictions in the electricity grid, and we are looking into how to better manage those limitations and improve that and maximize the value of renewable energy, so that we can see further deployment of renewable energy systems in the near future. As a university, we are involved. I would say that there are three really activity streams in this project. There's the Data Clearing House project, which is an initiative that we are not really involved in. CSIRO is really managing that. But as I will explain in the next slide, this is really it's a kind of a data broker that looks to bring together building owners and data providers to be able to connect them so that there is a better management of energy loads in those usually large commercial buildings. I'll talk about Living Labs, which is the main really stream that our university is part of. I'll talk about that in length in this presentation, and then I'll also discuss what we call the Integrated Design Studios, which is an initiative managed by the University of Melbourne, but we are also participating to deliver some of the sub projects in this stream. So I will cover those sections in blue in my presentation. I briefly mentioned that the Data Clearing House is really enabling building large buildings to become more, I would say, smart, engage with data providers and building management system companies to be able to not only provide monitoring, but also controls of HVAC loads in their buildings. The Living Labs are real buildings where we are deploying our monitoring systems, and we are monitoring those buildings. And then after a period where we have established a baseline in terms of energy use and renewable energy generation and some other key performance indicators that I will mention briefly in my presentation. Once we have all of that, and we have just completed that stage, we then invite technology providers where they come forward and they bring their technologies to be evaluated as part of the project under a real operation scenarios. The design studios are really classroom activities that you bring together people from consultants from different disciplines coming together with students and academics, trying to improve that early design stage of buildings and enable the thinking between the different disciplines to become more integrated and look into how we can bring those ideas of making the buildings more sustainable and enabling renewable energy integration in the buildings right at the early stages of the building design, which is something that is not really happening in most situations. So I'll start with the Living Labs. There are several sites that together with QUT we are deploying our monitoring equipment, and then we are doing technology evaluations. In brief, we separate those into healthcare sector Living Labs and education Living Labs. I'll just briefly cover those that our university is involved. There are 2 schools in ACT, and there is an aged care facility here near Wollongong. There are also 2 sector-wide projects that ourselves and QUT are managing. In these projects, we're mostly involved with the education one, and QUT is managing the healthcare one. In these projects, the sector-wide analysis projects, we are looking into establishing baseline energy use and renewable energy generation and some other key performance indicators for the ACT schools across the whole state, but also now we received some additional funding to expand that and include schools from New South Wales and Victoria and other schools where data are available, where we can get the data. Now the Living Labs, okay, there's something in the chat. Okay. The Living Labs, really, as I mentioned, they are real buildings where we are using a set of KPIs that we developed to evaluate their performance in terms of enabling a better value for renewable energy. But they are also the test beds where we are going to get technology providers to bring their technology forward and evaluate those technologies in relation to enabling a better utilization of renewable energy. We develop what we call a RITSEF KPIs, the Renewable Energy and Enabling Technology Service Evaluation Framework, to look into the kinds of things I mentioned at the start of my presentation, shifting those HVAC loads or energy loads in general from buildings towards the periods of the day where we have generation of renewable energy. And you can see this graph here is the generation of PV over a typical day, while the other loads that you see here are from a random building. This is not a school building. From a random building, the demand. So we're looking into making those charts, the lines much better with each other. A set of KPIs that we developed. I don't have time to go through each one of them separately, but you can see the relevance to this kind of crowd here that we looked into different types of impacts, impacts to society. Arena is interested a lot around those KPIs here in the middle, and also sector-wide benefits in general. So I won't go through those. In ACT, we've got two schools. We've got a very old school from the 1980s, Faden School. It uses a lot of gas. And we have another school that was built in 2005, a very, very large school, about 16,000 square meters. It's called the Amarus School. I'll briefly go through those schools in my presentation. For the Amarus School, we didn't have funding, of course, to monitor the whole school, so we monitor sections of the school. There is renewable energy generation on site, which we are also taking into account. We deployed our equipment, weather station. We're measuring temperature, relative humidity, CO2 in classrooms. We use watt watchers to measure sub-circuit electricity use, and we're getting the data to our database through LoRaWAN network. And we're also looking into gas. Go through the results here, but we have quantified we're using our KPIs. The first round of the RITSEF evaluation has finished. Again, I won't go through those. Also looking into different classrooms, as you see here. This is for the Amarus School. Here at the bottom, and on the vertical axis, we've got temperatures. These are box plots. I'm not sure who is online here. Typical academics would be able to read these charts very easily. What you see here, perhaps I would just mention that the dot value here in the middle is the median value, and what you see in the dark blue bar in the middle is the 50%, the 25% above and below the median value, and then you've got your outliers and so on. So these are really temperatures measured over a period of probably close to a year, 9 months, and you lump them together for one classroom, and you see, for example, that the horizontal line is the 18-degree line, that for this classroom, which is a transportable classroom where you expect the performance to be relatively lower than your typical school classroom, you see that there is a significant portion of the time that during the year, the temperatures were below 18 degrees. And this is only during occupied hours. So we excluded weekends and the hours after 3 p.m. and before 9 a.m. and so on. So in general, this school is relatively temperature. We looked into time series graphs. We analyzed our results and we put them in context in terms of comfort ranges, temperature ranges, and so on over a period of, now it's more than a year, but this one, that it's I think this is a 9-month period. Then we've done the same for CO2, which is a very a very topical topic nowadays, where we look into bringing kids back to school and we want to have fresh air supply requirements. This was the project started before COVID, but this is really during the mild COVID season in Australia, where we looked into, again, with box plots. Typically, you will say that you don't want your CO2 levels to be above 1,000 ppm in classrooms. Again, we have several instances in this school where we got that. I will not have time in 20 minutes to go through all of the results, but you can see that this school, about 21% of the time, the CO2 reading was above 1,000 ppm, about 1/5 of the time. So 1 day per week, really, the CO2 levels were above 1,000 ppm. We've got time series plots here, and you can see when those CO2 values on one instance, they reached up to 2,600 ppm for that day. I think that day was selected randomly. So we've got all of this data. We know now how the schools behave. We've done the same for the Faden school. I won't go through in detail through the results that we got there. Again, we got a few issues with comfort there in terms of temperature, but CO2 was much better in that school. Not many instances above 1,000 ppm. Despite that this is the older school, perhaps it was more leaky. We're not sure of why this was happening. And again, this was during spring. In winter and summer, you close the windows because you've got your HVAC system running. So we are suspecting now that schools have higher ventilation requirements, that things will become a little bit more, I would say, negative, because in February, for example, when it's very hot outside, the HVAC system, the air conditioning system may be working while the windows are open. So yeah, let's go figure what will happen in winter. Something similar will probably happen with a heating system. Again, no significant issues with CO2 here, although there are instances of high CO2 levels in the classrooms. We develop a whole of life planning framework to enable the government, the ACT school government, to be able to take decisions on how to purchase air conditioning systems by accounting for things that they are related to energy savings, sustainability, cost savings, so an integrated approach. So we developed that document, and I thought I had a link in my presentation, but it looks like perhaps my OneDrive didn't update the presentation. I thought I had a link where you can download that and have a look at what we have inside there. For the aged care facility, we did again something very similar. I'll just skip a few slides because I'll probably run out of time. Again, CO2 levels, we got our graphs there. No significant issues. They are much better performance than the schools. The same with the temperatures. It looks like that the air conditioning system in the facility is doing the job that is meant to be doing. We didn't find significant issues where you can see low temperatures or very high temperatures in both summer and winter. That is a very new facility, I forgot to mention. And the system is doing what is meant to be doing. So we are looking there onto more, I would say, left-wing kind of technologies, where demand response technologies, we are looking into evaluating demand response technologies, looking into evaluating wholesale electricity supply to the facility. I'm just gonna move to the integrated design studios. I'm suspecting I'll probably have another 5 minutes or so. So this is more or less what we are doing for the living labs. And I cut down a lot of slides from my presentation before this meeting here. With integrated design studios, we're working with University of Melbourne, and perhaps I should mention what is an integrated design studio. These are workshops that take place in classrooms at the start, and consultants are coming together. We engage a client who gives us a real project. So we've got, so far we had 4 of those run at Wollongong. And we have 4 consultants coming in every classroom. In every week, we have 4 consultants in classrooms working together with the students, addressing a project that the client puts forward for a design for a building. And I'll go through what we had so far, but the idea here is to get the architects to working together with engineers to enable a collective thinking of how we can improve designs during the early design stage. And in this way, we can enable a more integration of renewable energy and more passive design solutions in buildings at the same time. So these studios are a win-win project incubators. The clients win by accessing for free early ideas of what the new building could be. The consultants, architects and engineers, they get paid by ARENA, but at the same time, they get to network with both clients, ourselves, and between them. And the students, of course, are able to work in a very real project, a project they're working outside the classroom, ready to start consultancy projects, or almost ready, I would say. Students, yeah, they benefit, and the university, of course, gets research outputs out of this and industry collaborations. This is an out-of-date slide. There are a couple more companies that they are involved in these projects. So I'll skip that. Here in Wollongong, we run 4 integrated design studios. One of them goes around the Ribbonwood Library in Dato. The other one was the aged care building at the Innovation Campus, the Health and Wellbeing Precinct. The other 2 sites in this case were given by the first one by the Illawarra Local Aboriginal Land Council, and the other one through a foundation was a site by the Lighting Ridge Aboriginal Council. And the students started producing great work out of these projects. They've done a site analysis where they looked into things, solar paths, prevailing winds, and so on in the paths in the projects. They developed huge matrices where they put together various design solutions that they came about, and they started ranking them initially without very detailed calculations, but then later on we moved into detailed analysis, and these design solutions are very relevant to the crowd that we have here today. You can see the consultants working together with the project, with the students in the class. We had site analysis, talking with the client here, engaging as much as we can. I'll skip a few of those. The same with Lend-Lease project. The students gave presentations to both the clients, the consultants, and ourselves. They brought forward several good ideas that they were interrogated by the consultants, and they were forced to think on how to beat the business as usual cases. So as part of the project, they had to benchmark their ideas against the business as usual cases that we see out there. And for the other two, the Aboriginal projects, the students, we're running them this semester, and the students started developing visualizations that later on they will be installing PV systems and so on to quantify those relationships between energy demand and supply. Again, a lot of design solutions for all the buildings of the studies in the matrices, and some very great ideas and detail analysis that the students used computational tools to quantify. On particular one, as an example, this is the Dapto Ribbonwood library. One of the students looked into detail how to modify the parking and enable carports with PV panels on top for electrical vehicle considerations in the future. And I'll skip those observations, but we have seen some differences, working with existing buildings versus working with plain sites is very different. So, but in both cases, you need to enable that renewable energy integration thinking in the designs or retrofits. And I'll stop here with this slide, if that's okay. I probably took more time than I should, Clayton.
Thank you, Georgios, for that wonderful presentation. I've also just dropped into the chat some of the links to iHub. So a lot of the reports that Georgios was mentioning and further details on all of the stuff that Georgios had just spoken about can all be found freely available via that link. I think in the interest of time, what we might do is just move forward straight into Leela's presentation. If you do have any questions for Georgios, feel free to jump them in the chat. I'm sure Georgios will be able to answer some of those as we continue, and then hopefully we have some time at the end for some more questions.
Yeah, I can type. Yeah.
Thanks, Georgios. Do you mind stopping your share screen, and we'll get that Leela's up. Fantastic, thank you. Take it away, Leela. We can see that.
All right, thank you. Thanks, Clayton, and thanks, Georgios, for taking us through the iHub beforehand. I'm going to talk about another initiative that we are involved in at the Sustainable Buildings Research Centre, and this is called the Sustainable Homes Challenge. I'm just getting my slides to work. There we go. So the aim of the Sustainable Homes Challenge is to bring together university students this year from around Australia and from a wide range of disciplines to develop innovative solutions to the problem of providing sustainable, healthy and affordable homes. So the Sustainable Homes Challenge was dreamt up in around 2018, 2019 by a group of academics within the Sustainable Buildings Research Centre and some of the colleagues as well from other faculties. And what they wanted to do was provide an opportunity for students to dream big about some of the big problems that are facing our world and to think about what they can actually do and to explore some innovative solutions to some of these challenging problems. The program's being financially supported by the University of Wollongong's McKinnon Walker Trust. So Ken McKinnon was a previous VC of the university and he and his wife established this trust to support projects that really stretch students' experiences and give them opportunities to explore things outside what would be their usual framework of their studies. We've also got some industry sponsorship for this challenge, and this industry sponsorship is providing particularly prize money towards the students. They're giving them an incentive to work towards. This year, our industry sponsorship is being provided by the Housing Trust, who've come on as the major sponsors and have provided a case study for us to use. And we also have support from Engineers Australia and from BlueScope Steel. So the challenge was initially started to run in 2020, and the aim was to run it internationally. Unfortunately, you can imagine trying to run an international event in 2020 posed a few issues, and we had to cancel it at the start of the year. But we were able to reframe it and to run it this year just with a focus on Australian students. So as I mentioned, the aim is to get students working together in a diverse team. So not just engineers or architecture students looking at housing, but getting students from all over disciplines to tackle some of the real world and complex problems that look to address the UN Sustainable Development Goals. And when we start looking at which goals we're trying to address through this project, we've highlighted, 5, but I think there's more that are starting to come out when we start to look at the many different aspects of these problems. The other aim is to provide the students with access to some of the industry leaders, to give them some skill development workshops on skills that will help them in their future careers, and to also provide some training and some mentoring throughout the challenge, just to help them to develop their abilities and their skills so that when they go out into the workforce, they have a good grounding in sustainability and in how they can address these issues in the work that they do. So the challenge we gave them this year was to design a home that incorporates innovative components from waste-derived building products. And as I said, the Housing Trust came on as our major sponsors, and so they've essentially acting as the client for this project. And they've provided us a case study design of some townhouses that they've recently built. They literally opened last week at Corrimal. So the project requirement is looking at low-income housing. There's a focus on sustainable design, but there's also this added component of innovation looking at waste-derived materials. So the baseline design that were provided by the Housing Trust is this 4-bedroom townhouse. These were, as I said, recently completed. Now we allow the teams to choose their own occupants, but they need to be people who would be occupants of this house, so low-income housing tenants. And that gives the teams scope to explore different opportunities. So we have some teams who are looking at Indigenous families. We have some teams who are looking at extended families, so multiple generations living in the one house. We have teams looking at single parent families, refugee families. We've got a real broad depth of occupants that the teams are looking at. They did need to keep their design within about 10% of the base area. So it's a 150 square metre townhouse, which is fairly typical size for something this big. And it needs to be a maximum of 2 stories. Now, beyond that, we've given them the Housing Trust design guidelines that they can kind of use as guidance. But what we're really looking for is sustainable design that maximises the use of waste-derived building materials, but then also starts to look at what are the needs of the occupants, how are they going to live in the house, and how can we make the design something that is not just inviting and comfortable for them to live in, but something that meets their needs, is healthy for them, and helps to address some of the other social needs that they have. Now, just a note as to why we're looking at low-income housing, it's estimated that there's over 1 million households in Australia that are living in housing stress. Now, that means that they're spending more than about 30% of their income towards housing needs. And there's also a link here between people who live in housing stress, also often live in energy poverty, so they aren't able to afford to heat and cool their house appropriately. And that means that they're living in uncomfortable housing. So there's a real need for not just affordable and low-income housing, but housing that's actually going to be sustainable and is going to provide the thermal comfort for these people, but also not giving them excessive energy bills that they can't afford. So when we've asked the students to design these houses, we've given them quite a broad set of evaluation criteria to hit. They're broadly categorised into 4 different categories. So the first being sustainable, we want them to look at things like the materials that they use in the life cycle analysis, and what happens to the building at the end of its life. Can you recycle the components of the building? Can you deconstruct it? Can you take it down? Can it adapt if the occupants change? All those sorts of things. We also want the buildings to be healthy, to ensure that they're meeting the needs of the occupants, so that there's no nasty chemicals that are being introduced, particularly if using innovative construction products, but also that they're meeting the needs of social and cultural interactions of the occupants with those around them. And we need the housing to be affordable. So looking at the energy requirements that people can afford to operate and live in these houses in a way that's comfortable. But then other aspects like the value proposition of the house. Is it something that could be marketable? Is it something that could be upscaled and used on a larger scale? And does the supply chain for the innovative materials that they're looking at actually exist, or how can those supply chains develop in order to develop these designs? And then underpinning all of this, we have innovation, because we really want the houses just to be innovative and to get the students to think outside the box and come up with some amazing designs, because that's honestly one thing that students are great at, is thinking beyond the standard things. So why homes from waste? It may sound a bit strange trying to design a home from garbage, but when you think about waste that is generated in Australia, and the circular economy and the need to design circularly is starting to gain a lot more traction, especially in the construction industry. And part of that is because the construction industry generates about 44% of all the waste in Australia. It makes an enormous amount of waste. So in 2019, that was about 27 million tonnes of waste. And overall, the waste generation in Australia is actually starting to decrease per capita. The changes that people are making and the way that we are living is starting to have an impact, and that waste is starting to go down. But we keep building more houses, and we're not doing enough in construction to change. And so construction waste has actually bucked the trend of the overall waste generation in Australia, and construction waste has increased by 30% over the last 13 years. So this is obviously something that we need to address and we need to improve on. Now, a lot of construction waste is recycled. It actually has quite a high recovery rate, around 70 to 80%, but that still means that we're sending 20% directly into landfill. But even that stuff that is recycled, it's mostly concrete and the heavy masonry materials that are recycled. But typically they're just downcycled. They're made into aggregates. They're used in roads. They're used in places where the value of that material isn't really captured. It's a low value product. Now, another statistic to note is that buildings consume up to anywhere between 30 to 50% of the available raw material resources in the world. So not only are we making a lot of waste when we're building, we're actually using a lot of the raw resources. So really, to close the loop, we need to look at ways that we can reduce the raw material consumption of buildings, and we can take advantage of the value that is in waste, to see it as a resource and to see ways that we can actually use it productively and to make things that are worthwhile. So back to the challenge, the scholars that we have. We currently have 27 students involved. We started off with 30 and the numbers have fluctuated a little bit because this has been a fairly challenging semester for a lot of students. So understandably, it's difficult to balance all the needs. We have 6 universities involved in Western Australia, South Australia, the ACT, Victoria, as well as Wollongong, obviously. And there's too many disciplines to specifically list, but we have students from architecture and civil engineering, architectural engineering, environmental engineering, computer science, economics, social geography, social work. Education was another one that I didn't list on there. So we have a really broad spread of students, and we had almost about a third split between architectural kind of orientated students, engineering orientated students, and then a third of our students are from other disciplines, to really bring in that people element and that other worldview. And one of the biggest feedback we've got so far from the students has been that they're loving working in these interdisciplinary groups, that they're really gaining a lot from being around other perspectives and just people who think differently. And that's really challenging their worldview and how they approach the problem. So the timeline, we started in July this year, and we've been running alongside the Standard University session with our groundwork phase, which has been purely online, not even withstanding the fact that we would have needed to anyway. And it's composed of some online workshops and challenges, some online courses that we've provided for the students to take them through different concepts that they need to consider. And outside of that, they've been working in their teams to work together to develop their design and their ideas. They've just finished their concept development last week. And so from now until finale week, they'll be working to develop that design a lot further. And then we have finale week, which is in the last week of November, first week of December. And this will be a week-long virtual intensive. It would have been in person if that had been allowed. But instead, we're going to run it virtually. We've got a whole heap of things planned for the students with guest speakers, some virtual site visits, some challenges, to get the students thinking about design from all perspectives, but then also how that relates to what they're designing in their house. And then at the end of it all, there will be an opportunity for the students to showcase their designs. I'll come to that a little bit later in a public forum, and just to show us their designs, after which they'll get some prizes, and we'll get the industry to come in and judge that and see how it goes. So some of the groundwork phase topics that we've covered, I mentioned we've run a bunch of online modules, and we've covered a whole heap of topics from things like teamwork, circular economy principles, problem identification, sustainable housing design, passive design, energy performance, materials, life cycle assessment, design demonstration, and even pitching. So kind of how do you take these design ideas and how do you communicate them effectively? And then finale week, I already kind of talked through most of the things that are involved in that. And it's just the main thing to note that the designs that the students develop will all be available online at the end of the challenge. So we'll actually host them through our website, including their video pitch and including some form of display of the designs that they come up with, so that there'll be a really interactive format that community can engage with, that everyone can engage with, to see what the students have come up with and the ideas that they have. So if you'd like some more information, we do have a website. The website is just there, but it's also on hosted on the EIS, so the Engineering Information Science webpage. And if you go to our website and have a look, you can also see we've got a few blogs from the students coming out. So I think there's about 5 up there at the moment and more to come. And these are just opportunities to meet some of the students who are involved and what they're getting out of the challenge. And there'll also be some links to our Homes from Waste Symposium and finale event, which is on the next slide. So the final showcase that we have will be on the 3rd of December. And this will be completely free and open to anyone who's interested in coming along. We're going to kick off the morning with a symposium where we invited a bunch of industry and academic speakers to take us through some of the key challenges and the key opportunities that exist in this space when we think about homes from waste. So we'll have some sessions looking at circular economy and construction of what's being done, as well as reducing construction waste. And there's also a virtual poster session that we'll be running alongside that as well. The link for the webinar is here, so you can go along there if you're interested and register now for that. And you'll be sent more details as it becomes available. And then following that symposium in the morning will be the showcase of the team designs in the afternoon. And that will just be an opportunity for the teams to show their pictures, to take us through their designs and how they approach the problem. And as I said, at the end of that, there'll be an announcement of prizes and the outcomes for the students. Now, I don't want to give too much away about what the students have been working on. So this is just a little bit of a taste and a snapshot of some of the designs that they're working on and some of the things that they're coming up with. And I won't go into too much detail because I really look forward to the students presenting their ideas. So if you're interested, come along in the 3rd of December and you can hear what the students come up with. But this just kind of gives you the snapshot of some of the creativity and some of the ideas that are going through their heads in terms of thinking about the place, the design of the house, the materials to be used, how they can design sustainably, and how they can maximize the interaction of the people within their designs to make something that's going to be really amazing for the occupants. All right, and I'll just finish there. I finished with our website, so if you want to go along and check out what some of the students are doing, or at least hear their blogs. But otherwise, we look forward to being able to share with you more in December when we see some of their outcomes.
Fantastic. Thank you very much, Leela. That was a very inspiring presentation on some of the work that's happening. And the same from Georges, some of the work that is happening amongst the Sustainable Buildings Research Centre. So if anyone has any questions, feel free to jump in the chat, raise your hand, and we can always get you to open your mic and ask. I just wanted to start off really kind of almost a question for both of you. But I'll probably throw it to Leela. The Integrated Design Studio is bringing together, a range of disciplines, and the Sustainable Homes Challenge, as you showed, with the 27 students from a wide range of different areas. I guess, how important is it, do you see this kind of multidisciplinary approach in tackling some of the challenges that climate change is throwing at us moving forward?
I think it's immensely important. And one of the things that we highlighted when we were sharing this with the students is that these sorts of problems are not problems that can be approached by one particular point of view. So you can't just come at it as an engineer and say, here's a problem, here's my solution, I test my solution and I get an outcome and it solves the problem. There's a whole heap of other considerations that need to come into things. And that's why, especially exposing the students to different viewpoints and understanding that you might have one solution, but it actually impacts other people. And what you create as your design solution is going to have flow-on effects, or it might have things that affect it that we don't even think about. And so that's why having different viewpoints and having people come together helps to open up your mind to see different perspectives, and also different ways to approach the problem. It's very easy to get a fixed mindset of how to solve problems, but these are not problems that we can, climate change isn't something that we can just find in a textbook answer. If it was, we would have done it and we would have fixed it. There's a lot of other things that come into it, like how do we balance out the needs of different people? How do we make the financial implications balance out against the environmental performance to achieve a solution that actually benefits everybody economically and sustainably. And those sorts of things really come from getting different people together and thinking about different ideas.
Yeah, absolutely. And especially, I guess, right at the early design concept stages before any major decisions are made. There's a couple of questions that I know, Georges, you've kind of already addressed them in the chat already, but I still thought, given the timing of all this, it's probably worth just asking anyway. Over the last couple of years, we've seen a lot of big hurdles come at us. We've seen the largest bushfire season in Australia's history, with, immense issues with smoke right across the country, essentially. And then following that, we were faced with COVID, where, with the bushfires, it was all about how do we seal our buildings up and keep the air inside clean, to now with COVID, it's how do we actually open these buildings up to bring as much fresh air in as possible. And I guess with climate change, we might see, more extreme heat events, possibly more bushfires. Like, how do we actually look at these sorts of issues in some of these living labs and in schools and buildings in general?
Yeah, the living labs have a limited scope, but these are good questions, Clayton. You now have, you will need to enable designs that they are very flexible. So if you've got two opposite, or three probably opposite concepts here, you've got if there are bushfires, you've got to find a way not to allow outdoor air coming in the classrooms or whatever building you may have. But at the same time, with COVID, you need fresh air, or you need to find a way to mitigate that. And on the other hand, you've got energy. So if you open your windows and you're running your air conditioning system, you're wasting really energy easily. So you've got to, in some way, it's good to have all these issues right now, because I'm optimistic that innovation will enable solutions in the future, and it will force us to start thinking on how designs can address some of these really at the start. Right now, at least what we found in IDS, Integrated Design Studios, the renewable energy part, the match between supply and demand is not really considered. It's all about operational functionality of the building, and it's all about cash flows. It's all about good value for money and so on. but in some ways, I'm optimistic that all these issues will force us to start innovate.
So what are some of the technologies that, like you've mentioned in chat here, ERVs, for all of our audience that don't understand what an ERV is?
Yeah, so this is really bringing fresh air in by recovering some of the heat that you are wasting of the building. So it's a heat exchanger where you are bringing air in, but you are indirectly putting that air in contact with warmer, let's say it's winter, warmer air from the indoor space, or while you're trying to, and that warmer air is really not fresh anymore. It has been exposed to CO2 levels inside the space and so on. So you're exchanging that heat, and the incoming air, which is cold in winter, is preheated compared to just opening windows. Yeah.
Absolutely, and just that was one of our key initiatives that we took with Dubai with our solar decathlon house. Yeah. Being that we're in extreme temperatures, we didn't want to waste any of that energy that we'd spent cooling the building down, but we needed to bring in fresh air to keep the CO2 levels right. So these sorts of technologies are a fantastic way to save energy but still meet the needs of fresh air. Do we have anyone else in the audience that has any burning questions that they'd like to ask of our panel here?
I think, Clayton, sorry, I had in the chat and George answered it. So I was just really interested in, obviously, as the world gets warmer, and if we don't keep below the 1.5 degrees, do we have the technology to meet that? And I was thinking about all the discussions we've had this week about health, and just the amount of people dying from heat-related deaths, and yeah, it's just heating and cooling is such an important topic.
Of course, yeah.
Moving forward.
Yeah, it's a significant part of the building energy usage. Probably more than half in most cases of your energy is for heating and cooling. And we have the technology, but it will cost us energy, I guess. So we don't want to go through that route, because you've got all sorts of other issues. Energy is CO2 emissions, and it's also cost. So the envelope of the building is not built for that, for sure. The envelope, the traditional minimum regulation standards, they're not built for that. We're still, I'm looking at a single glazed window in front of me, and I know that this room in winter, I cannot be in here.
Yeah.
Unless I bring a couple of radiators in.
Yeah. Interesting. Thanks.
Yeah.
Yeah, and I think you've really hit a big issue there, a nail on the head. If our design standards aren't looking towards the future, we also carry with us all the existing building stock that we already have and are continuing to build that may not address the buildings that we need in 20, 30 years in the future. So it's a big issue. Is there any other questions?
If you guys could just take care of that this week, that'd be great. All those brains in the SBRC, make that happen.
There is actually a review of the National Construction Code happening right now, and the SBRC has been doing a stack of work in trying to help put forward our thoughts and some of the work that we've discovered throughout our research to help guide.
There are good things happening. The Department of Industry, I forget the acronym now, Energy, DISER. Yeah, they commission studies on thermal bridges, improving that aspect of the building, which is the weak aspect of the building. And they're going to introduce that in building regulations. But yeah, you cannot go from A to Z, I think, immediately, because that you've got to consider the other players, like the Property Council, which is all about, how much it will cost to move from A to Z immediately.
Interesting, though, with something like COVID, we went from A to Z pretty quick.
Yeah.
But I guess the thing that did is it opened up this discussion where now, CO2 levels in spaces are in the news. It's everywhere. And the education, I think, that's spread across the general community from air quality. Most people wouldn't have even considered what parts per million, smoke particles are in the air. But all of a sudden we've had a massive educational awareness campaign almost through these drastic disaster events. So. Well, I guess that's essentially time for us. I wanted to thank both of our presenters today. So thank you, Georgios, and thank you, Leela, for those inspiring presentations. And it's great to see so much work that's going forward to help contribute to helping solve some of the problems that we're seeing come through climate change. And a lot of that is coming from the students that we actually have at UOW participating through some of these programs as well. This recording will be live as well online later. So if need be, please feel free to share it with your colleagues if they haven't had the opportunity today. But thank you for joining us today, and enjoy the rest of your Friday and have a lovely weekend.